Solving equations using multiplication or division. So, remember from the last video, inverse means the opposite. The opposite of addition is subtraction. We could also say the inverse operation of subtraction is addition. These are synonyms. You can use them interchangeably, okay? Mean the same thing. So today the equations involve multiplication and division. Now notice I'm using a little shorthand in my notes, but I say the real word when I'm reading it, and that's what you can do too to help you take notes. So we're going to use the inverse operations of multiplication and division. What is the opposite of multiplication? Division. And what's the opposite of division? Multiplication. That's what we're doing today. So here's our example. 3 times x equals 12. I know you know the answer, all right? I'm not saying what times 3 is 12. That's what you did back in 4th grade. What I'm showing you today is how to do the proper notation for solving this, because this is going to be a little piece and a big problem in, as you go on in math. All right, that was your little lecture. So the operation here is multiplication because this is 3 times x. So the inverse operation is, it's like a drum roll, division, okay? So we are going to divide both sides by 3 because this says 3 times x, so the opposite of 3 times x would be divide by 3. And it's very important that you write it like I do. I do not want the line with 2 dots floating around, okay? Part of the reason I'm showing you things today is to show you the proper way to write it. So we're going to divide both sides by 3. And it always has to be both sides because otherwise it's not an equation, it's not equal. You've only done something to one side. Now you know in fraction land that anything over itself is 1. So 3 over 3 is the same as 1. In the last video, I crossed it out kind of with a slanty line. Here I'm going to cross it off with more of a straight line so that it looks like a 1, because you know it is a 1. And as mathematicians are efficient, I'm not going to write the 1x, I'm just going to write x, because anytime we only have 1x, we know the coefficient is 1. Bring down my equal sign in a straight line, and now 12 divided by 3, 4. And once again, I box the answer. And you can check. So remember our first problem, the problem was 3 times x. I'm going to substitute the 4 in for the x because I'm telling you x is 4. Okay, right there, x is 4. So 3 times 4, remember when we substitute, we put the number in parentheses when it's multiplication. Okay, you don't put an x because that's a variable now. 3 times 4 is 12. Here's my original problem, and now I do the work. 3 times 4 is 12. The reason that's important to do this step is because what if you did this part wrong and for some reason wrote 5? Then when you plugged it in here, substituted, you would say 3 times 5. And hopefully then you would say, wait, 3 times 5 is 15. That's not 12. I made a mistake, and go back and figure it out. That's the whole point of the check. Here's another example. Negative 5 times x is 45. Once again, the operation is multiplication. So the inverse is division. Divide both sides by whatever is multiplying your variable. Here it's negative 5, so I divide both sides by negative 5. Do you notice how I'm just doing the fraction bar line for division under the 5? I don't need to put it under the x because we're saying negative 5 divided by negative 5, which is 1, because anything over itself is 1. So I have my x equals. Now remember, when we are dividing or multiplying, if the signs are different, the answer is negative. So I write down the negative first so I don't get my problem wrong because I forgot the sign, okay? Be efficient and write it down first. Now do the work. 45 divided by 5, 9. So my answer is x equals negative 9. Now to check this, I'm going to substitute it back into the original equation. So x is negative 9, so negative 9 gets substituted for the x. I can't say that enough. So here I'm going to substitute it in parentheses. Negative 5 times negative 9 is 45. 2 negatives in multiplication make a positive. So 5 times 9, 45. All right, now let's do some problems that start out as division problems. So we'll do the inverse operation of that. X divided by 8 equals 4. So I know you know the answer, okay? That's not the point of this. The operation is division, so the inverse operation is multiplication. Multiply both sides by 8, because what we are doing to the variable is dividing it by 8. And we want to do the inverse, the opposite. But please write it like I do. I don't want to see you writing this below the problem, okay? I don't want a little x8 floating around somewhere. So what we're going to do is, because this is a fraction, you remember when we did our last problems, we needed the same number in the numerator and the denominator to make it be 1. So I'm going to multiply with parentheses up by the numerator, because if I really wanted to make my line longer, you could see now that there's an 8 in the numerator and denominator, so 8 over 8 is 1. And then I'm going to multiply this side with parentheses, if I can draw them, by 8. Once again, now our problem looks like it did before. Okay, before we had a multiplication, so we were dividing. Now we have division, so we're multiplying. But 8 over 8 is 1. So we just end up with 1x. And then here we multiply. Before we were dividing. Now we multiply. 4 times 8? 32. Box your answer. In our check, we're substituting the 32 in for our original x. So now it goes in the numerator. 32 divided by 8 is 4. Is that true? Yes, it is. 4 equals 4. Yay! I like to draw the happy face because I'm happy I'm done with that problem. Okay, here's another example. X divided by -6 equals -2. What am I dividing x by? -6. So do the inverse operation. Multiply both sides by -6. Put it in the numerator. Put it on the other side. Okay, I'm not having a dot floating around. I'm not having an x. It's up in the numerator so that I can have a number in a numerator, the same number in the denominator. Over itself, it's 1. Okay, anything over itself is 1. I don't know, that's a sideways 1. But x equals, negative times negative is positive. So figure that out first. 2 times 6 is 12. Now to check, we just plug this 12 right in for our original x. Here's the 12. 12 divided by -6. Uh-oh, it's not a negative anymore. Well, it's not supposed to be a negative because we want our answer to be negative. Positive divided by negative is negative. 6 goes into 12 2 times, and it's a negative. Yay! All right, we're going to do 2 more problems. X divided by 4 equals -7. We are dividing by 4. The inverse operation is multiply by 4. With parentheses up in the numerator. With parentheses next to our answer. Anything over itself is 1, so it cancels out. We don't write the 1 down because we don't want to have to write more than we need to. Bring down our x, bring down our equal sign in a straight line below the other equal sign. -7 times 4. Is that going to be positive or negative? I hope you said negative. -28. Now to check, our answer goes in where the original x was. Substitute it. -28. Negative divided by positive. That's going to be negative. -28 divided by +4 equals -7. Is that true? Yep, it is. Yay. All right, last problem. X divided by -5 equals 4. What are we going to multiply by? -5. Sometimes it gets a little squishy. So leave yourself plenty of room. I wrote example too close, huh? All right, -5 numerator, -5 denominator. Anything over itself is 1. X equals. Positive times negative is negative. 4 times 5, 20. Yay. Let's check it. The x was in the numerator to begin with, so that's where I'm going to substitute. -20 over -5. Now look, the signs are the same. Two negatives in multiplying make a positive, and that's what I have here is positive 4. So positive and 20 divided by 5 is 4. Yay! Most important thing, please remember to show me the work correctly. That's what I'm going to be looking for tomorrow in class. Okay.